Alright guys, today we're going to talk about prime factorization and the least common multiple. So prime factorization is when you break a number down into all of the multiplication that it goes into. So for example, 45. 45 is 9 times 5. 5 can't break down because it will just be 5 and 1, and that's prime, so we know just 5. And then 9 breaks into 3 and 3. Then we circle what the smallest of ones are, so we'd circle 3, 3, and 5. And then 45 is written as 3 times 3 times 5, or 3 squared times 5. The prime factorization of a prime number is just itself. So for example, 23 is just 23, because it's prime and we never use the number 1 in a tree. So, excuse me. Still getting over that little sinus infection thing that I had last week, so it's been great. So we're going to find the prime factorization of each of the following numbers. Write your answers using exponents whenever possible. Excuse me. So 15 is just 3 times 5. And since there's no other ones, my answer is just 3 times 5. I don't like to use the x because I don't want to be mistaken for an x. So I'm going to use my dot for multiplication. 36. Well, there's a couple different ways to start breaking this down. We know we could do 6 and 6. That works. 6 is 2 and 3. 6 is 2 and 3. None of those can break down anymore, so I have 2 squared, because I have 2 of them, times 3 squared, because I have 2 of them. Well, we already talked about 23. He's prime, so my answer is just 23 there. 22 will break down into 2 and 11. And 2 is prime, 11 is prime, so my answer here is just 2 times 11. 45. I want to make sure I'm not writing on my face. 45 will give us 9 and 5. 9 is 3 and 3. So it's 3 squared times 5. 17. He's prime. It's just 17. 48. What isn't 6 and 8? So I get 2 and 3, and I get 2 and 4, and then I get 2 and 2. So how many 2s do I have? 1, 2, 3. So I have 2 cubed times 3. Something doesn't seem right. That's why I missed one. I have 1, 2, 3, 4. It's like 8 times 3 isn't big enough. But 16 times 3 is. So he's actually to the 4th power. Number 29 is prime. Okay, 195. Well, we know we at least have 5, right? And what? 195 divided by 5 is what? 39. And we actually had 39 in our notes, and that was 3 and 13. So that's 3 times 5 times 13. And my last one, 392. So I did 4. So it's 498. And 4 is 2 and 2. Oh, I think 98 can be divided by a bigger number than just 2. Nope, maybe not. 98 is 2 and 49. And we know 49 is perfect. 49 is 7 times 7. And 7 and 7 are both prime, so I have 1, 2, 3 2s. And 7 squared. Excuse me. All right, least common multiple. Multiples of a number, the multiples of a number come from multiplying the given number by whole numbers. Fair enough. The least common multiple, or the LCM, is the smallest multiple that two numbers have in common that is not 0. Not 0, so it can be 1. So, for example, let's look at 6 and 10. 6, the multiples of 6 are 12, 18, 24, 30, 36. 10 is 10, 20, 30, 40. So the least common multiple of 6 and 10 is 30. So multiply. So we're going to multiply today. So we're going to just list the first 5. So 9 times 2 is 18. Times 3 is 27. Times 4 is what? 36. And then 5 is 45. 4, 8, 12, 16, 20, 14, 21, 28, 35. No. And then we need 24, 36, 48, and 60. So, again, just multiplying those out. Find the least common multiple of 6 and 8. All right, so some of these, we're going to list all the numbers. Some of them we're not, because we can just see the answer is going to be another one. So 6, I've got, I'm sorry, 6, and I've got 12, and then I've got 18, and then I've got 24, and then I've got 30. Of 8, I've got 8, and 16, 24. I found it. Answer is 24. 9 and 18. Sometimes the answer is in the problem. Haha. Tricky, tricky. 5 and 20. Again, this is just like the one before. It's 20. 3 and 7. Now, sometimes it's going to end up being the number they multiply to. So this one actually is 21. 2 and 120. That's 120. 5 and 11. It's 110. All right, that's all I had for you.